Welcome everybody, members, visitors. Great to have you along with us tonight. So without further ado, it's my pleasure to introduce Mark, VK30HM, and John, VK3 Whiskey Mike Fox, to talk to us tonight about astrophotography. So thanks Mark, thanks John.
Well, welcome everybody. It's a double header tonight. I'll do the first half and John will do the second half. It's a bit of a story about my personal journey in astrophotography, and hopefully it will be useful for others. There's some useful information. First of all, many of you here tonight probably know a lot more about astrophotography than I do. I do not claim to be an expert, but it might be interesting to hear how I got to where I got to. It's taken me 60 years to get my first acceptable image of some deep space object. Most people who are interested in the sky start out with one of these telescopes that you buy at Australian Geographic. I think I got my first one at age 10 and fiddled around with it, and until 3 years ago it's all I had. They're very cheap, but they're very difficult to centre on the target, and unfortunately the targets have this terrible habit of moving. So even if you can get it in the viewfinder, in a few minutes it's not there. If you just want to look at the moon and some planets, they're probably okay, just. But you can't see any deep space objects at all, really. The only one you can probably see is the Milky Way, but that's just so big that you can't miss it. But anything else, they're just too dim. You can't see them. I found it deeply unsatisfying, and quite frankly, I wouldn't bother with that sort of setup. So, in line with my philosophy of go big or go home, I went out, I lashed out and bought myself a 200mm Newtonian telescope, focal length 1 metre, an HEQ5 Pro equatorial mount, a ZWO camera, ASI air controller, everything, all the bells and whistles. It cost me about $4,000, I think. I don't want to think how much it cost, but it's the ant's pants in telescope systems. It's pretty heavy. It's 52 kilos, and it's very fiddly to set up. It takes about 30 minutes to plug everything in and align it and get it all going and calibrate it, find south, do all sorts of things. So how'd it go? Well, not well, really, quite frankly. I'd set it up in the afternoon, and by the evening the clouds came over. So I'd have to tear it all down and take it inside. And unfortunately, where I set my telescope up, it's up a hill. So I had to carry it all up the hill, set it up, and then I had to carry it all down the hill. This happened 4 nights in a row. And I just decided I wasn't meant to do astrophotography. The elements, I never got a single image. I did learn a lot about astrophotography in a theoretical sense, but I never used it. I could never use it. So I put it in my shack and it sat there for 3 years rusting. And then I went the complete opposite direction. I bought myself one of these smart telescopes. They've been on the market for about 3 years or so. They're pretty recent. I am aware of, this is a C-Star S30, There is also an S50. There's also an S30 Pro. And there's the Dwarf 3. And John will talk about that. It's completely and utterly automatic. You plonk it on the ground, you turn it on, and it goes, zzz, yeah, I know where I am. And then you just type in, well, what would you like to photograph tonight? There's no setup or adjustment. It cost me $700 and it weighs 1.65 kilograms. It is amazing. I can easily carry that up the hill and I don't mind too much having to bring it back down again. You can take that camping. It's just incredible. It's not as good as the big system I had, but I'm getting a lot more use out of it than the previous one. The focal length is only 150 millimetres, where the other one it was 1 metre. That just means that the magnification is not as large as the big system. And it's got a relatively small aperture, which just means you have to have longer exposure times. So it's not really a big problem. Other than those sort of physical limitations, it's got superlative control software. You run it off your phone. You've got an app on your phone. There's no eyepiece. You can't look through it. You have an app on your phone and you can control it totally from your phone. The range of the Wi-Fi is very good too. It means I can sit inside my house and operate the telescope. I don't have to be out in the cold. So that's an added benefit. Now, what's in that little box? I don't understand how they get it all in there, quite frankly. It's got 2 lenses. It's got a wide-angle lens and a telephoto lens. It uses the wide-angle lens to look at the whole sky, and it looks at the stars and it says, yep, I recognise those, so I know exactly where I'm pointing. It does a thing called plate solving, which means looking at a dozen or so bright stars, it knows exactly where it is. And once it knows, so it calibrates itself. Once it's calibrated, you can have the telephoto lens for proper imaging. It has an apochromatic lens, you'll have to Google that, but it's better than the normal achromatic. It's got a smart app on the phone for star finding, tracking, shooting. It'll run on its internal battery for 6 hours. It's got a light pollution filter. That's a mechanical, an actual lens filter. It's not too bad. It's got an AI denoise function, so it'll automatically remove some of the noise that you'll see. It's got a dew heater. If you leave it out overnight, you might get some condensation on the lens in particular, and that's not good. It ruins your images. So it's got a dew heater. It's got a solar filter, so you can image the sun without destroying your telescope. It's got an ASL mode, which is just azimuth elevation, but it's also got EQ mode, equatorial mode. You have to mount it at whatever angle, whatever latitude we are, and it will run in equatorial mode. You get better images because it's only tracking in one axis then, not 2. You use equatorial mode if you want longer exposure times of about 30 seconds. It's got a scenery mode, which I haven't used yet, but you can, for instance, focus it on a bird in a mangrove swamp or something or other, and as the bird moves, it will follow it. So it's really good for bird watching. Haven't tried that yet. I'm not into bird watching. You can also track aeroplanes. If you can lock onto an aeroplane, it will follow, take an image of it. It's got 64 gigabytes of memory, so plenty of room for images internally. And I say again, 1.65 kilograms. It's amazing. How did it go? Well, brilliant. In the afternoon I brought it home from the telescope shop. I didn't read the manual, of course, and who does? And I got my first image of the moon, which is what you saw on the title slide. I just turned it on and typed in moon and it went zzz, and it took the pictures. It's amazing. On subsequent nights I got images, and it varies. It depends how bright the thing is you're photographing, but between 10 minutes and 30 minutes to get an image. But you don't do anything, you just say photograph NGC 51, M51, and off it goes. If the clouds come over, it doesn't matter, just pick it up and walk away. I operate it completely remotely from the comfort of my shack, so I'm not even outside. I'm inside with the air conditioning and the coffee on tap, looking at the skies. It's opened up a whole new world that I've been sort of trying to get at for 60 years, but never understood how to do it. Well, this is the easy way. Now, just to give you an example of what it can do, that's the telescope pointing at the Helix Nebula. And that's what you will see if you look through a telescope. You'll see nothing. It's there. All you can see is a few stars. It's way too faint for the human eye to see. Also, it's emitting in infrared, visible and ultraviolet, so your eye can't see it anyway. You need to integrate the light over a period of time if you're going to see it. And with a cheap telescope, without a camera, you'll never see these deep space objects. They're just not bright enough. That on the left there is an exposure of 10 seconds, and you can just start to see there's something there. You can see a red ring. Can you see that? There's a hint of something after 10 seconds. After 10 minutes, yes, now I can see it properly. If I stuck at that for 30 minutes, I'd get a brilliant image. Not many of these things emit invisible light. They're all ultraviolet or infrared. There's a few which have got a bit of visible light. But the camera has a very, very wide bandwidth. Now there's this dreaded thing called light pollution. And they measure the amount of light pollution on the Bortle scale. There was a guy called Bortle who invented this scale. If you live in the centre of Melbourne, the sky looks like that. There are no stars. You can't see anything. If you live out in the country, you see that. Lots and lots of stars. And there's a whole scale of 1 to 9 of how light polluted it is. Now, around this part of the world, we're about a 6. You can see stuff, but it's very muddy and there's lots of light pollution. You've got to go out into the country. And I happen to be going to Wilson's prom this weekend, and that's Bortle 1. So I'll come back, I hope, with lots and lots of images. I'm going to take some images from home, so I'll see what it looks like in a Bortle 5 or 6, and then I'll compare them with the ones. You can't really see, this is the Milky Way, you can't really see that here. But when you go out in the country, oh, it's amazing. So I hope to get some good images of that. Now there's a light pollution map, and we are here in that horrible purple mess where you can do astrophotography, but it's challenging. So here we are a 6. Where I live, it's a 5. I still do lots of good imaging, but I have to use lots of light pollution filtering, and I have to do the AI denoising, and I have to manipulate the images to make them look pretty. But this weekend I'm going down here. That will be a lot better. Now, there's several different planetarium programs that are quite fun. If you go out to do astrophotography, the question is, well, what am I going to photograph? What's out tonight? The app on my phone will tell you. It says, well, these are the 10 best things tonight. But if you actually want to see it, I use a planetarium program called Stellarium. And I can actually, I've taken a 3D, a 360-degree photo of my viewing position. And so these are the actual trees and buildings and stuff in my backyard. So I can see easily what can I see and what can't I see because there's a tree in the way. I can see about 50% of the sky only. It's enough. But this allows you to plan what's out tonight, what's good viewing. Yeah, so you can put your own actual backyard horizon into the program. There's another one called Telescopius, which is sort of similar. There are several of them around. Well, what's the future for my astrophotography? Well, I've got about 4,000 objects in the catalogue that I can image. So I'll work my way through those for a few years. And I'll probably upgrade to the S90, which doesn't exist yet, but it will. These things are really, really taking off. They're selling like hotcakes. So if you were thinking of getting a smart telescope, and they're a lot of fun, this is a C-Star 30. There's now a C-Star 30 Pro, which is the same, except the camera array is twice as big. And then there's the Dwarf 3. We can't really work out which is better or worse between the S30 and the Dwarf 3. They seem to be very similar in capability. They're very cheap. As I said, I paid $700 for mine, but it's now $600 because the S30 Pro came out. And for me, it's just not viable to carry around 52 kilos of equipment and spend a half an hour fiddling around setting it up. This, I just plonk it on the ground, off it goes. It's so light that you can take it camping with you. If you're into astrophotography, a good place to join is the Astronomical Society of Victoria. They're quite large and quite active. They run sky parties where everyone takes their telescope to a local park, and it's like a hamfest. We all wander around and talk about telescopes instead of radios. There's a Stellarium program. If you want to look at the sky, there's Telescopius. The cameras I use are ZWO, and unfortunately for me, there's a telescope shop in where I live, which is a big mistake. If you go in there, it's an awesome shop. Leave your credit card at home. It's got so much. It's like the toy shop. It's just mind-blowing what they have. All right, I'll hand over to John. He'll talk about the other and show you some images.
Like Mark, I sort of went through the same sort of process of astrophotography. I always had an interest in photography and then astrophotography, and spent a fair bit of money on bits and pieces and cameras and different telescopes with the same results, basically. It's very frustrating. The guys who are really into it and go out with a truckload of gear and go out the bush and set themselves up, they can get results, but I'm really not into that. I want something that's easy and cheap. And this is what I've got, is the Dwarf Labs 3 camera, which is basically the opposing brand to what Mark's got. So I don't know which one came out first. They've been on the market. Well, the Dwarf Labs 1, and there was the Dwarf Labs 2, and the Dwarf Labs 3 was released about a year and a half ago, I think. So there's probably a 4 coming out soon. There's also a slightly smaller form factor Dwarf Labs, one that looks a bit more like Mark's, but it's a smaller one for more, they call it pocket version. But it comes as this kit, very much like Mark's. It has this pair of sunglasses that comes with it. They're down there, which is for those who are familiar with the ND filters, it's actually 100,000 ND. It's about welding glasses. So this means you can, and it's the same thing that Mark's got, a similar thing I think on his, and that will allow you to face this thing at the sun in full sunlight, and I'll show you an image a bit later on that. So there's a kit that you get, and like Mark's, you run it from your mobile phone and with an app, a free app that comes with it. It connects via Wi-Fi, Bluetooth and Wi-Fi, and it also allows you to run the Wi-Fi in your home in STA mode so that you can actually step it through your own internal home Wi-Fi and extend the range. Or you can run it directly, Wi-Fi to it from the phone. So, these are the kind of images you can get. This is the Orion Nebula, which is one of the earlier ones I got. It's in the Orion constellation, and as you can see, it's a very large nebula, and one that comes up nice and clearly. In a minute, when I show you the size of the sun on this, it'll give you an idea of how big that is in the sky, because the focal length of these gadgets is all the same. That's, I think, one of my favourite ones, the Orion Nebula, but there's a lot more to see up there. It will depend on the time of the year, of course. Right now, Orion is very, very visible. It's about up there somewhere, depending where north is. You can see it very clearly above your head. Now, bear in mind, that was recorded or done at Glen Iris, which is very close to the city. So Bortle about here, maybe even worse, because there's a lot of light pollution in my backyard. I've got a small backyard. And that would have been done over a period of about an hour, maybe, 3/4 an hour. It takes 4 shots per minute, and they're 15 seconds exposures. And then what it does is stacks and eliminates the noise, and an AI program inside it extracts all the noise from it, and just you end up with a true image rather than most of the noise. So that's the Orion Nebula. Horsehead Nebula, which is also part of Orion, one you're probably quite a famous, the Horsehead one. That's in the bottom part of the Orion, and this is part of Orion's belt, in fact, here. So there's the stars of Orion's belt. There's another star here. That's the Carina Nebula, which is one of the big nebula up there, and these are all visible right this time of the year, actually. Generally in the summer, these are high overhead. The Swan Nebula, see, that's a much smaller nebula, and you can see why probably see why they call it the Swan. You can see the neck of the swan there. I tend to call that the Nose Nebula. I think it looks more like a nose sitting out in space, frankly. But I hadn't heard it called that by anybody else.
You have to use your imagination.
Yeah, you do have to.
Some of these.
But I mean, if you look at the nostrils there, and anyway. So as you can see, the star field, it shows a lot of stars there. I mean, something you'd never see looking up into the sky where we are in the city. String of Pearls Galaxy. Again, you can see why they called it that. That's one that's less visible now, I think. Probably shot that probably earlier in the year, probably late winter. The Helix Nebula, which you saw earlier from Mark. Eagle Nebula. I'm not sure why they call it the Eagle, but anyway, I'm sure you can see whatever you want in them. The Lagoon Nebula, that's not visible right now. That's visible in the winter. When I first bought this was last August, and that was very visible in the sky then. Cat's Paw Nebula, not as distinct, but again, you can see why they call it the Cat's Paw Nebula. And bear in mind, these things are a long way away. I mean, most of them are at least tens of thousands of light years away, even if they're in our own galaxy. Our own galaxy is 100,000 light years across, and we're about 24,000 light years from the centre of the galaxy. So a lot of these objects are within our own galaxy. String of Pearls galaxy, not obviously, that's external. And anything in the Magellanic Clouds, which is in the, I think that's in this large Magellanic Cloud. That's the Tarantula Nebula. You notice a lot whiter, a lot less colour in that. It's just the spectrum light that generates. Most of these nebulae, I don't know if you're aware, but are caused by exploding stars, basically. Stars that have reached the end of their life cycle and have exploded and have now a gas, expanding gas from the explosion. The Pleiades, Seven Sisters, that's a well-known constellation of stars rather than nebula, but you can see them very clearly there. They're quite low on the horizon now at this time of the year, but quite visible. Now, the Moon. This gives you an idea of the focal length of the device. Now, the focal length is fixed. You can't zoom in as such. You can zoom in on the image itself once you've created the image. But that gives you an idea of the size of the imaging that you're creating. So all of those images you've seen before, unless I've played around a bit with the image, relate to that size of the Moon. This is interesting because this is the sun. And if you look at the sunspot activity there, it's very clear on that. This was only a month or so ago when there was some particular aurora happening and trashed HF bands as well, sadly. But that was the thing that was causing it. And if you go, as it goes round, it will, the sun is rotating at about 24 rotations per, 25, at the equator it's about 25 per month. A full rotation is takes 25 days, sorry. So I have got a sequence of these where you can see that these sunspots are moving around. And of course, when they're facing us directly and really playing up, that's when we get aurora and obviously CMEs, which affect our communications. So, questions for Mark and myself? Is any?
Yeah, you get little messages as it's collecting the images and stacking them up. It says, "Oh, Starlink detected, image discarded." So it filters out, and it's about 1 in 20 images will be lost because of Starlink. That just means you've got to image a little bit longer than you might have had to. It runs on a smartphone, but there's a thing called NINA, which is how you can remotely control any telescope from anywhere. So you could run NINA and connect. I don't know what NINA stands for, but so you could run that and connect to your telescope and see it on a PC. These things are all networked. You can see other people's telescopes and what they can see. There's a community where you upload your images and you can see what other people are getting from their telescopes. It's just like amateur radio. They're all very friendly and...
View the images directly?
Yes.
Yeah, absolutely. I speak for both. The cameras work a little bit differently, but they're fundamentally the same. The way in which
you can download the raw images, and there could be hundreds of them, and you put it through. There's many programs. One's called Cyril. I don't know what that stands for either. But you can post-process your images and make any colours and any filters and anything.
Yeah, I use Lightroom actually sometimes to, which is a commercially available bit of software to zip up some of the images if I want to make them a little bit more. I
just use the software that's in the telescope itself. Yeah. It's good enough.
It does. That's something I didn't mention.
You can do video and you can do time lapse.
Yes, star trails and that sort of thing. are all available. The star trails I find somewhat boring. They're just streaks in the sky. They all look the same to me. But certainly, yes, time-lapse and video, absolutely.
Is it possible to turn AI off?
Yes.
Look at pictures, warts and all?
Yeah, it's off by default.
It'll be interesting to see.
You do an image, and if you decide it's a bit noisy, you just press the AI
Right.
fix that, please button.
I'd be interested to see the images of
Yeah, I don't have it before.
Elon's pollution.
Well, yeah, I don't have images of those because they get discarded.
You mentioned about the nebula mostly being in infrared and ultraviolet. So, and then you've got a picture that's invisible.
Yes.
So I imagine that they kind of pick a spot in the middle and kind of compand
It's
the
all
wavelengths in. So
it's all-
something
it's all
in
false-
infrared
it's all
ends
false.
up being
Yeah.
red,
It's
and
all
red
no,
ends up being
No.
more...
no.
No?
It's all completely false colour. It's all made up. You can have anything, any colour you want.
Just like the song.
It's not the real colour. You can't see the real colour. So they shift the colours down to something you can see,
Yeah, it's
and that mapping is anything you want. Well, that's what it does. It's got the camera is very, very wide bandwidth, taking in both ultraviolet and infrared, and you compress that down, but
indivisible.
it's indivisible. But the actual resulting colour is anything you want. It just makes it up.
Given the focal length that you've told us about, and you gave us a sense of that by showing us that shot of the moon, would that mean that you wouldn't in fact get very good photos of planets?
Yeah, that's right.
That's right.
You can image them, but they're quite small. It's not good for planets. You need a big telescope for planets.
Yeah.
But you can see I can see Jupiter, and I can see the moons,
Yeah.
but they're quite small.
You can't, and it doesn't blow up well if you...
Well, you can digitally zoom by about 10, but after that, it gets a bit pixely. So no, it's not for planets, but there's not many of those. I'm not really interested in planets. There's 4,000 of these nebula things. They're much more fun.
How would you compare the smart telescope that we've seen here with the more traditional unit that you showed before, but with a smart controller and smart tripod?
Well, the traditional unit, the big unit I had before, had a smart controller. It's actually the same controller. That's got a ZWO ASIR Air controller in it because it's the same manufacturer. Yeah, the big telescope works exactly the same. You just type in, I want M51, and it goes, there we are.
The imaging must be much better, surely.
Yes, its magnification is much better. The imaging is the same. It's the same 4K sensor, but you've got much higher magnification, so you can do planets.
Has doing this kind of work led you to read more about the astronomy?
Oh, absolutely.
Yeah.
Absolutely. I've spent 60 years being very frustrated by not being able to do very much. And even during that period, you do a bit of reading and you learn a bit of stuff. But once I got real images, I went, oh, this is fun. And you really start reading up about it and really researching into it. It gets very technical. It's just like amateur radio. It gets extremely technical if you want it to. There are forums out there, I've got no idea what they're talking about, but it sounds good, what they're talking about.
And I guess it makes you realise that the universe is, say, infinitely out there, that for all the bodies in the heavens are really like packed one-on-one. And the further out you go, you're seeing more and more density of stars.
Well, they did a famous experiment where this guy got, I don't know which telescope it was one of the really big ones, and he focused it on the darkest part of the sky, where everyone said, well, there's nothing there. And so he ran it overnight, and there were millions, if not billions, of galaxies in that dark spot. So you just can't conceive of how many stars and galaxies and stuff there is out there. It's enormous. I think it was the Hubble, where they said, well, we'll photograph the darkest point in the sky and see what's there. And the answer was, well, there's a lot there. We need a bigger camera.
Never going to get there.
Well, they're going to do the same thing with the James Webb, I suspect. And
Yeah,
there'll be
absolutely.
even more stuff out there. Still need a bigger camera. Well, we need a telescope on the Earth and a telescope on the Moon, so you can set up some sort of interferometer, and then you'll have a really big telescope.
Absolutely.
That would be true of most of them.
Well, Betelgeuse is probably the best example of that comes to mind right now. Betelgeuse is part of the Orion Nebula, or not nebula, the Orion constellation. That's what we're looking for. It forms part of the shoulder, and it's the red star, and it's about 680, 700 light years from Earth. They think it may have already blown up. It's a red giant. They don't know. But if it blew up in the 17th, 16th century, 15th century, we still won't see it until the 22nd century. It could blow up tonight. We might look up tonight and see this nebula forming. And apparently when it does, it's going to be brighter than the moon during daylight. So it's actually going to be visible in daylight. But it could be another 100,000 years before it does it. So it gives you a bit of a perspective. But that's one that they're looking at. And they say the reason they're looking at it a bit closer was that a couple of years ago, I think about 10 years ago, they noticed it was brightening and darkening quite substantially, and it was acting differently. But they've also found it's got its neighbour that's flying around at another smaller star that could be causing that. So there's all these things happening out there. But yeah, these things are happening all the time, but we're not going to see them, obviously, until the light reaches us. I mean, if the sun blew up now, well, during daylight, it'd be 8 minutes before we saw it happen. So it wouldn't blow up until 8 minutes later for us. Yeah, since I've had this camera, the Dwarf 3, I can't speak to the other one, but the Dwarf 3, there's been about 3 firmware upgrades, each of which have been quite good and have really been, that's an added advantage, yeah, and both in software and firmware on the device itself. Bear in mind, a lot of the processing is done inside it. This is really only the controller, becomes a controller. Most of the processing and the stacking is all done with inside the gadget, all the processing.
I get a new firmware upgrade about once a month. It's a bit annoying, quite frankly. Every time you turn it on, another bloody firmware upgrade.
But I have to say, the ones that have come through for me have been advantages.
They're worth it, but the software's not stable yet.
Bear in mind the fixed focal length. So, I mean, meteors, a large meteor.
With the auroras, you can use the scenery mode.
Yeah.
To photograph that sort of thing. And comets and that, they're all in the catalogue.
We're getting a wind up.
Well, no, you're not necessarily getting a wind up, but it's been very, very interesting. And I'll never look at stars in the same light as I have learnt so much tonight, and I've forgotten more than I've learnt already as well. So thank you very much, John, Mark, for sharing this. We lived in a great age, everybody, haven't we?
Absolutely.
The developments and the opportunities we've had to take benefit and learn so much using, and we've got to respect it all. Thank you very much for your attendance this evening. There's tea, coffee, water, some bickies. I think there's still a few left. You might even find a piece of licorice. And if you want to stay around, you want to talk with these 2 gentlemen up here, come up and do that too. Thank you to the online community for bearing with us as we've run this program tonight. Look forward to seeing you again all very soon. But in the final effort, please put your hands together for Mark and John. Thank you.